Hi everyone, I'm Xiao. I, with my co-presenters, Karam, Diaby, and Zhang, are excited to present you enhancing HTA model adaptation with AI, leveraging large language models and R-HTA for local cost effectiveness analysis. So it's important to make this disclaimer that the opinions expressed in this presentation today are solely ourselves, not our employer, Otsuka Pharmaceutical Companies. So for this presentation, I'll start with some opening remarks, set up context and objectives, and then Karam will be discussing country-specific requirements and the approach that we propose, the concept presentation. And then Alan will follow with a case study to demonstrate how to use large language models and R-HTA for model adaptation. And finally, we have some key takeaways. So as this audience may be very familiar with the HTA process, global pharmaceutical companies usually build global HTA models, such as cost-effective model in the beginning, and then local affiliates, they adopt these global models to their local markets. But oftentimes they face challenges such as limited manpower, limited access to country-specific data, and other bandwidth constraints. So which will lead to the adaptation process being manual, slow, and error-prone. To potentially increase the efficiency and improve accuracy, we're proposing an approach that combines large language models and R-HTA. And again, to bring everybody to the same page, large language models are AI tools that understand and generate text, helping HTA teams automate data extraction and interpretation and fill local data gaps. R-HTA is an open source framework that enables the creation of interactive and transparent web applications from R. So we hope by the end of this objectives, we can achieve by the end of this presentation, we hope to achieve these objectives to simplify and accelerate local model adaptation. And hopefully we could show you how to enhance reproducibility in economic model involving local adaptation. And eventually, we can free up teams from to focus on conceptualization and interpretation rather than data cleaning. So now I'm going to pass over to my colleague Karam to talk about country specific requirements and the concepts. Karam?
Yeah, good afternoon, everyone. My name is Karam, and I'm very excited to be here today. So as Ong was mentioning, we're taking the perspective of pharmaceutical companies, but it could be other perspectives as well. Why we're talking about global model adaptation. So as you know, if you're working with a pharma that has multiple affiliates, countries where local adaptations are needed, we pick a country that based on the pipeline, we think that is going to be the first country where the model is going to be used. For example, the UK, or it could be the US, whatever country that is. And when we develop the model, we try to take into consideration different sensitivities in those countries. But then, when the time comes, when those models are developed, then we have to work with local affiliates to really parameterize the model such that it reflects the realities of the countries. So here, this slide is to kind of align on the fact that there may be some clinical differences, guidelines, and the way care is provided in those countries that require to be incorporated in that process. And also, cost variations, cost in the UK may be different than in Canada, for example. CAT, as the Canadian Agency for Drug and Therapeutic in Health, may have specific needs in terms of the type of data that they need to see in order to validate the models. There are also epidemiological differences, incident survival, and it's important to capture those, and also preferences in terms of the type of utilities to be used in the model. So what are the consequences of kind of, omitting or ignoring these elements? It's, HTA rejection or loss of relevance. So then, the challenges in that process of model adaptation could be of various nature, and we'll focus on a few here: data and availability, or difficulty accessing data. It could be that there's not the same documentation of the models in the different countries. And that process can be time consuming because there's a lot of manual parameters updates. And if you think about it, some countries may or may not have necessarily the manpower and the know-how to really deploy those models. And so some companies may have platforms that they use to communicate with affiliates. And also there's a risk of human error in everything that we do. So as Hong was mentioning, what we're trying to do was to explore the use of AI as part of our process to help us kind of speed up that process. And we kind of summarize here some of the actions that would need to be taken in order for that to happen. So number one is to identify what are the model components that need a localization, meaning needs to be adapted for the country of interest. And that will depend on the model and on the country. So in terms of how we can use AIs to kind of parse the model files that we'll be using in order to source the data that we'll be using in the adaptation. And the next step is to extract those local parameters. And this is where we start doing the prompt engineering and looking at local data sets that might be of interest for the specific country or the HTA agency. The third step is to search and recommend replacements, write intelligent data queries in order to find the most, I would say, appropriate data that needs to be used. And there's this dynamic aspect associated with, the model, because things change to tend over time. And we also have to ensure that there's quality control and that we document the generation of those parameters, because as you know, HTA agencies, they have high requirements in terms of evidentiary, requirements. So I'm introducing the case that we're using to demonstrate here the, the value of using, the LM and R-HTA. And essentially, we have this publication that was done about 2014, and this is a breast cancer kind of specific case. You have the publication reference here, but here is a simple Markov model, 3 states, where you're looking at a patient that suffered breast cancer, and this is based on the clinical trial at the time, where you may have patients that are stable on without adverse event. They might develop adverse event or progress. Once they progress, they're lost because these are interim data from the clinical trial. So there's no mortality as an absorbing state here. Progression is the absorbing state. So essentially, it's a Markov model comparing monotherapy versus combination therapy. The time horizon is lifetime, and we have 6-week cycles incorporated. And the case is to really use that US-based kind of model and then localize that for the UK and HTA requirements. So I'm gonna get ready to share the floor with my collaborator Alan to go into how we kind of implemented that as part of this case study. So Alan, whenever you're ready, I can move the slide for you.
Yeah, sure. Thanks, Tom and Karam. Yeah. So yeah, it's very exciting. This is Zhen. To continue this conversation, a case study using large language model and the R-HTA for the country-specific models. So in this example, as Karam Home nicely lay out the structure of the Markov model with three different states. So we're going to use two countries as an example, like UK as well as Canada. So for UK, you can see in the listed parameters are the key input for the Markov state model. And for the meaning we have the costs, utilities, and also transitions. So you can see the input could be different for different countries based on local regulatory or HTA body recommendations or guidelines. And the utility will also vary by population in each country or region. So this is like a illustration how we can leverage R, especially Shiny, which will call the large language model in the background to do a seamless updates of the models upon your selection of the specific market or country, so that you can have a more efficient like a generation and sensitive quantification. So. All right, so if you can move to the next, so we're mainly talk about, so whenever we use the large language model inside R or the statistical software, so it is quite important to provide certain context when you trying to prompt to the chatbot, right? So we want to have a more targeted like a parameter input grab from the AI rather than like a general topic. So that's why we introduced the AI-powered retrieval augmented generation or RAG. So the RAG is like when you send a prompt to the chatbot, you provide more specific content or the fields for the AI to be guided to answer upon your selected questions. So including like a searching and in this case, in this example, it would involve searching localized clinical and economic outcomes, as well as the providing the potential traceability and transparency, which is a key point when you're utilizing AI to make sure all the data has a provenance and very explicit data source to validate. So this is like one example how we can leverage the large language model with RAG to provide context for the prompt. Everything is built into the R-HTA so that you don't have to zoom into the details of the background like calculation, as well as how you would get the large language model working within R. So in the next example, we'll use this like a model structure in the example how the prompt nicely layout. So if you can go to the next slide. So there are several steps for calling large language model in R. So first of all, based on the current like packages, typically you would require like the Python as an intermediate step to deploy the like as we were mentioned, when we build the RAG, you want to index those files and make them ready to be potentially called within the large language model. So that part is typically done within Python. So, but unfortunately nowadays we have a lot of bridges, right? Because R has been very flexible and extensible for foreign languages like Python or C++ in the backend. So the first step would involve a general simple R-HTA example where you would develop two core files. One is the server.r, the second one is UI.r. The UI.r is basically the user interface. You have the front end and back end, like what will be your output, what will be your input, and the server.r basically will do all the background calculation. In this case, specifically when you call the Python pre-rendered codes and the pre-indexed like the RAG database, that will all be done in the server.r. So and then once you build this R-HTA like the baby form, then it is important to have some intermediate step of preparing your RAG database. In this case, the database typically include like regulatory or HTA guidances, as well as like the literature review in each regions about the utility and also the patient's characteristics for different markets. So in our example, we'll show you you can prepare those data into different PDF files, like guidelines or published papers, those PDF files, a batch of those, as well as CSV, like a comma separated like tables where you have some targeted literature review to summarize your input by country for different topics and and the parameter fields. Yeah, and the final step would be use the R-Shiny to dynamically. So everything will be very simple user interface, right? So one-click analysis, and you have a simple drag-down menu or some buttons allow the users to select the country and circulate the model parameters by either specifying your files or leverage AI to fetch the parameters. So that's the 3 steps for the large language model with the R-Shiny. So we'll illustrate using some in the next slide. So you can see this is the typical interface for the R-Shiny. You have this is clearly one model input region, right? So you can see here the highlighted ones in the figure in the middle. Yeah, thanks. So you have UK and Canada. So upon your selection of the country, so all the model parameters will be automatically updated according to your selection. So this is a easy way, not working on the changing your R code, but just a very user interface to allow dynamic changing countries and monitoring the localized country-specific model results. So now this is the key part. If you look at the left, now we want to leverage AI, right, in the background of the R-Shiny. So the first step, as we mentioned in the previous slide, you're going to prepare your RAG database. So you can for different countries, you might have a structured folder, right? For some subfolders, you have each folder corresponding to different countries, and then for those countries, you have the corresponding guidance document in PDF format, as well as CSV files for the data or published papers or some of the regulatory documents. So this is one example when you have data for UK as well as data for Canada. So once you have all the data prepared in the structured way, then you would do some pre-rendering steps in Python, right? So this is the part where so far you can call a Python code in R, but essentially the core part will be done using some Python infrastructure. So you would index or let's call vectorize or embed those RAG database into something that's ready to be called. So that's in this example, we recommend using a DB, which is a nice tool to help you index or tokenize your RAG database into some local library. And then the second step, you can set up a fast API. In this case, we use an Onema API. This is a free open source tool that so that you allow you to set up have a certain prompt with your indexed RAG database without any cost, right? So so this is basically is one example that allow you to have a free call of the large language model in your potentially a personal laptop. So this is a very simple implementation. And then once you have the Onema API launched as well as the fast API and a setup, so everything here is just 2 or 3 lines in the a Windows prompt or Unix command line. So to set up all those, and now you have the R-Shiny based on, as we mentioned, the UI.R and the server.R, that you will be able to just you can see here, the red box highlighted fast AI parameters. So upon selection of that button, you will generate automatically update your model parameters based on a targeted literature review that based on all these RAG data and the language model from your prompt. So that's the one illustration of the workflow. How do you use the R-Shiny coupled with the large language model and the RAG to provide a real-time monitoring of the results for different countries for this model. So if you look at the next slide, we will briefly explain the data source as well as the
Could you
example
start to
output.
wrap up, please?
Yeah.
Thanks.
Thank you.
Yeah, sure. Yeah, absolutely. Yeah. So so as we mentioned already, so this is the comma separated file, and you have PDF files. So everything you can use them to build your database and provide a context for your prompt. So if you go to the next slide, that's going to be one example output. So whenever you choose different countries and choose the AI, so the most important thing is the transparency and the traceability. So it will tell you what pieces of the model input have been updated and what are references, what are the data sources for that change. And again, because everything is user friendly, so it will allow you to still make a further tweaks and then to see which one give you a reasonable model localization. So the key wrap up is basically, as you can see, this is one, at least it is possible and a easy like an implementation, even on a personal laptop with like a free version. So there's no cost. So of course, you can utilize a more computational power as well as like a advanced large language model, which might be costly. But again, and this is just showing the feasibility that you can integrate the large language model with R-Shiny to make this like a model localization to be more expedited for the implementation. Yeah. So that's all for the example. Yeah. So it's open to any questions or on the Karam. Yeah.
Excellent. Thank you very much.